This is a real human stomach, and we're going to take a look inside. If we open this up, you can see how amazing the inside lining of your stomach is. I mean, look at these folds. These folds are called gastric rugae, and they allow for your stomach to stretch when you decide to continue to eat because you've decided that the food is just way too good to stop.
If you like this content and are interested in our ebook or courses, please check out our website in our bio. If you like this content and are interested in our ebook or courses, please check out our website in our bio.
If the Earth is flat, how do you explain time zones?
So if it's a close sun, it would be kind of like a spotlight. The time zones work because that local light, just kind of like a flashlight, doesn't light up the whole circle. It only lights up a certain part of the circle.
I'm curious what the explanation is for gravity and things like the Coriolis effect.
Well, gravity's still technically a theory. We know that there's an up and a down. As far as Coriolis, I was in the military and I've shot weapons, and we were never once taught to account for Coriolis.
What kind of weapons, if you don't mind me asking, like ICBMs?
Well, when I was in the military, we shot M16s, and the railgun is a question because it can shoot 100 miles, and it's a line-of-sight weapon. So 100 miles using the curvature of the Earth, it just doesn't make sense that they'd be able to hit the target.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
When we ingest and swallow the alcohol, it will move down the esophagus and into the stomach. Now, if I open this other stomach, you can see the inside lining or the mucosal lining of the stomach. The reason I'm showing you this is because some of the alcohol can actually be absorbed through the stomach lining and into the bloodstream. However, this is only a small amount, but it is important to note that alcohol absorption and how fast it enters your bloodstream does depend on the contents of the stomach, meaning that alcohol is absorbed more quickly on an empty stomach. If, for example, there's fat and protein in the stomach, this will slow that small amount that can be absorbed through the stomach, and of more significance, this will also slow gastric emptying, essentially slowing the movements of the contents from the stomach into the small intestine. And the small intestine is where the majority of alcohol is absorbed. The term sciatica is used to describe pain that's radiating along the pathway of the sciatic nerve, and this can be caused by compressing a nerve root at L4, L5, S1, S2, and or S3. And the most common cause of this is having a bulging or herniated disc below L4 or below L5, compressing one or more of those 5 spinal levels that I just mentioned.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
This muscle is a muscle that many people don't like to work out in the gym unless they've got a mirror in front of them. This is called the trapezius. A lot of people nickname it the traps, and they do shoulder shrugs in front of the mirror in hopes that they can really get this part of the muscle to bulge or hulk out, if you will. Now, the funny thing is this muscle doesn't actually even move the shoulder joint. When we shrug our shoulders, we actually do something that's called elevation of the scapula. This bone here just goes straight up, and then the shoulder joint actually just comes along for the ride. Now, this trapezius muscle does a lot more than just elevates the scapula. It can actually extend the neck. It can even bring the scapula inward, which is called retraction, and even twist the scapula upward into upward rotation.
You're looking at a real human heart beating at 45 beats per minute, which is actually below the normal resting heart rate, which is between 60 and 100 beats per minute. Typically, you're only going to see athletes who are in great cardiovascular health have this lower resting heart rate. Now, this is seen to be more normal. This is double that last heart rate. This is 90 beats per minute. So, yes, it is in that upper aspect of the range, but still this is considered normal. And you can see that not only is the heart going to be pushing out more blood at this rate, it's also going to be working harder in order to do that. Now, this is actually 105 beats per minute. When you're past 100 beats per minute, especially as a female, this can be a worrisome sign for your health. And I didn't even want to go any faster than this because I was worried about actually damaging the cadaver heart. Just understand, you really want to have a much lower rate, at least within that normal range.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
Let's include a quick review here of how the hypothalamus and pituitary gland, which you can see in this sagittal head section, and here's the hypothalamus, and here's the pituitary gland, and the hypothalamus secretes gonadotropin-releasing hormone, which then goes to the pituitary gland and tells the pituitary to secrete luteinizing hormone and follicle-stimulating hormone. luteinizing hormone is the one we care about in this story because luteinizing hormone will circulate in the blood, and when it reaches the testes, it tells the Leydig cells in the testes to secrete testosterone, which you're looking at the inside of a right testicle here. The testes secrete the testosterone into the bloodstream, and once in the bloodstream, the testosterone will leave through the testicular veins, where it can then circulate throughout the entire body and have multiple effects. And some of these main effects are muscle and bone growth, influence on fat distribution, red blood cell production, libido, sperm production, and even influences mood.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
One of the more surprising dissection tools that we have in the lab is the bandsaw. Now, we don't use the bandsaw to be barbaric, but the bandsaw provides an invaluable tool to help us separate the bodies into different planes of space, such as cutting the body in the sagittal plane or maybe even in the frontal or horizontal plane. That allows students to view internal anatomy that you couldn't do in any other way, especially students who may be going into something, say, like radiology. If you've ever seen a CT or an MRI, it slices the body through the sagittal plane, through the frontal plane, and even in that horizontal plane, so that students, or in that case radiologists, can view the body in multiple different planes of space to help diagnose conditions and to view abnormalities.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
One of the common questions we get about the human stomach in the lab is, what's the size of an average adult stomach, or how much could you fit in there? Well, most average adults could get about 1 to sometimes 1.5 liters stuffed into the stomach. And just for context, this bottle is 500 milliliters, so the average person getting about 2 of those in there as far as volume. But the stomach is the most distensible, or you could say the stretchiest portion of the whole digestive tract. I mean, this thing can stretch dramatically when you think about, say, like competition eaters. Sometimes they're getting their stomach to stretch to accommodate up to 4 to 6 liters worth of food inside of there. That's ridiculous.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
What are your options if a kidney stone, and yes, this is a real kidney stone with the real kidney, gets stuck and it can't pass and go down the ureter? Well, there's a few options. First, they can actually do what's called a lithotripsy, where they use focused energy waves to try and pulverize the stone, and so that it breaks into smaller pieces that can then be passed down the ureter. Second option, they can do what's called a ureteroscopy, where they actually go up the ureter, and they can even use lasers to break apart the kidney stone and then have a basket attached to it that'll grab the pieces and then pull it out. Or another option is they can actually go the surgical route, where they'll go in here and take it out.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
Let's talk about shin splints. So first off, you can see we've cut a little window into the tibia here, and that allows you to see the medullary cavity, which is the hollow center of a long bone. But if we draw our attention over here, you can see this tissue called the periosteum. And periosteum is going to reside on the outside of compact bone. But periosteum is going to be loaded with nerve endings, bone cells, and a whole variety of other things. But you can see that it's continuous with this tissue here called the fascia. See, as I put my probe under here, you can see that they blend with one another. In fact, they're made of the exact same type of tissue. The only reason we call them something different is because they're in different locations. That's just how anatomy works. Well, in shin splints, you can get an overworked muscle which can actually start to tug on the fascia, which can then tug on the periosteum and cause an inflammation. And since it's loaded with nerve endings, that means you're going to get quite a bit of pain.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.
Now, even though it might be nice to have thinner subcutaneous fat so that you could see those muscles more clearly, that doesn't mean we shouldn't mention visceral fat. Visceral means pertaining to internal organs. So this would be the fat surrounding the organs. Here's the abdominal cavity. Up here's the thoracic cavity where you'd find the heart and lungs. Now, this particular body, or this dissection, is actually a little bit more tricky to make out specific structures and organs. And that's because it has such a buildup of this visceral fat. Like, look how thick and fatty this greater omentum is. You can see these thicker fatty appendages coming off the intestine and that buildup of visceral fat in between. What's even more remarkable is the amount of visceral fat around the heart. Yes, the heart is inside here.
If you like this content and are interested in our ebook or courses, please check out our website in our bio.